Director of Sales for IFM for the mobile market. This afternoon, we're going to be discussing the topic of IoT, which is the Industrial Internet of Things, and how it relates to the on and off highway market. For those who do not know who IFM is, we are a family-owned technology company that specializes in the automation of on and off highway equipment. With over 50 years of experience in industrial manufacturing, IFM is a reliable partner for the introduction and implementation of IoT solutions. Our products for the mobile market include sensors, cameras, HMIs, and control technology. IFM is now over 8,000 employees with 1.4 billion euro in sales from 2022. Digital transformation is certainly a very buzzy term these days, but how should we approach it? The manufacturing industry generates more data than any other sector of the economy. And because all this data is generated, companies are making data and analytics a priority. In a recent GE survey, 42% of manufacturers said big data is a top priority. And another 75 said it's one of the top 3 priorities. Most of the time, we're always talking about the what. That could be us, our competitors, the press. What is big data? What is sensors? We also talk about the how. How do we collect data? What do we do with it? How is this important to companies? How is this important for people's strategies moving forward for real-time analytics? But we need to understand the why. Why is it important? Why should we spend time on it, invest in it? And more importantly, why should people care about big data from the machinery? Before we approach the why, let's understand where we are today. So if we look at today and we look at general telematics, 85% of what we're doing today is vehicle tracking. That just knows where the vehicle is or the machine is at all times. It's very common data, everyone has it. And you can see, as we go around, 47% are looking at performance monitoring, 43% navigation, vehicle performance monitoring, and then all the way down here, you have order taking, dispatch, and proof of delivery. These are things that you see every day when you get an Amazon package. So as an example, we may address the how and the what here, but we don't give too much thought into any of the analytics that is going through here. These are very commodity-based information. So for example, vehicle tracking is used by 85% of the fleet owners today. It tells us where the vehicle is, but it does not tell you how the vehicle's been used, who's been driving it, how the operator's been using the machinery, and it doesn't tell you anything else. So right now, we see the digital transformation happening in 3 waves, and each of us are at a different wave. Wave 1 is the traditional model that we have. Basically, you buy a piece of machinery, and it's the classic ownership model. You pay a one-time price, and then any type of service or things like that are done at a cost. This is where most people live today. It's the classic ownership model. If we look at wave 2, we're now moving into the usage-based model. The customer pays for all the usage of the machine, but does not own the machine. And we use this example as machine as a service. So if you think about leasing a car versus buying it, you lease the car for a certain amount of time, but you don't own anything. The service is part of it. And the last is the outcome-based thinking one. Basically, you only pay for what the product is delivered. So if we look at Uber, no one really cares about a car. They just want to go from point A to point B. So Uber's changed the classic ownership model and the leasing model. You don't care what kind of car it is, you just care about getting from point A to point B. So how does this work in vehicles? So if we look at de-icers, for example, at many of our airports, they have a critical impact on all operations of a plane. And by staggering fluid refill stations throughout the airport, you can avoid bottlenecks. To do so, you have to have a real-time view of the current liquid levels in each truck. Additionally, the usage changes per aircraft, so based on the type of aircraft that you have, you're going to have different fluid levels. If we look at a refuse truck, they're constrained by weight and size. So basically, they can only pick up so much refuse based on the total tonnage or weight of the that's in the vehicle itself. So improving the speed of pickup, optimizing capacity, enables a truck to pick up more product in less time. This is only possible by accurately monitoring key body data and preventing unplanned stops. If we look at a mobile drill rig, this is a great example of highly complex on and off highway vehicles with a lot of data. So basically, the operator has to manage not only manage the drill operation, but also the safety around the drill head. So using area surveillance can assist the operator with their tasks and display the parameters of the cab, significantly improving the working conditions and the safety on the job site. Think about farming equipment. What if automatically you could identify weeds and eradicate them? This would reduce or altogether eliminate harmful pesticides on your crop. Cargo vessels are highly regulated, and there's very little time in between. You have very little time to basically unload your cargo. So using AGVs allow the transportation of containers basically to be simpler and faster, and knowing where each container is so you pick up the right freight at the right time. The automated machines are helping this very fast and growing market in the ship-to-shore industry. As you can see from these examples, the digital transformation has already begun and will impact every industry. So what does this all mean? If we look at the IoT for mobile vehicles, it starts with the data. You need smart sensors on your machine to collect and analyze data. So for example, the quality of the oil, the battery health, monitoring temperatures so you don't have too much heat, and looking at vibration and shock trends. This lets you know if the vehicle has struck anything or if it's unbalanced and potentially a motor gets damaged or something like that. The next thing is to take the data and put it into smart IO modules that can start calculating what this really can do for the vehicle. The last thing here is a collision avoidance sensor. This will help the operator conduct their job safer. It also will give you alertness of what the operator is doing and measure their performance. Functionality, if you look at asset tracking to know where machines are, what implements they are picking up, and where they're performing their job in the best way. So you need software updates that can be done remotely to save time and avoid unplanned stops. Finally, if you look at data that you want to record, you can send that from the sensor up through the gateway into the cloud. Now you can basically analyze the machine at any part in time, and you can also adjust anything that has to be done on the machine. If, for example, the temperature is high, you can adjust the fan, and that will help cool down the machine without the machine breaking down and having an unplanned stop. So in this example, you're using very smart sensors, going to the I/O module, which collects the data, having a camera to help the operator efficiently and effectively do their job, a safety PLC to make sure everything is running, a display for the operator to look at it, and then for all the service techs or engineers, you can send the data via the gateway and into the cloud. And vice versa, when you do, when you look at basically software updates, you're taking the data from the cloud and pushing it back through here. So you go to the gateway and then through Ethernet down to the different display controllers and PLCs. That allows for the machine to have the highest uptime possible. Service calls are very expensive. On average, a service call is about $3,000 per trip. And you can basically avoid a lot of these unplanned trips by having a smart system like this that really is your IoT for mobile vehicles. So with real-time maintenance, we can record the data from machines we use to predict what maintenance activities should be performed on the vehicle and when they should be initiated. As I discussed before, this can be as simple as a time-based maintenance or complex as using AI to understand the machine health. What are some other examples? Instead of operator fatigue being measured in hours, we can actually, or jobs completed, their performance can be measured on driver alertness using camera technology. Creating an operator scorecard allows for increased job satisfaction, a drop in insurance rates, and increased safety. Tracking tools and equipment on work trucks in the rescue industry can verify that the correct tool was used for its purpose and location. Additionally, it assures that expensive assets are not left on the job site and that the vehicle has the tools it's needed to perform the job. Real-time diagnostics and troubleshooting eliminate the need to deploy the service technicians with their laptops, but rather provides critical data either locally or remotely so the operator or engineer can evaluate and troubleshoot problems. As machine development time cycle decreases, most OEMs need an easy way to update their machine via software. So what is the IFM's role in this? So IFM, we're working hard to understand everyone's why and what impact the digital transformation will make on the industry. This will also help us develop solutions so you can upgrade your machine for Industry 4.0. Sensors will provide the critical machine data and functions, cameras to assist the operator in avoiding collisions and help react to potential problems, I/O controls to help reduce complex wire harnesses for ease of installation, setup, and troubleshooting, hardened controls to provide data from components, engines, transmissions, and other critical vehicle functions for machine intelligence. HMIs to collect and display vehicle data and improve the driver experience. Telematics will provide the machine knowledge regarding productivity, operator performance, real-time alerts, and remote services as software updates. This revolution is beginning, it has started, and everyone is in that different space. So IFM is here to understand the why, help provide the critical components and solutions to automate your machine for 4.0. Is there any questions? Yes, sir.
When it comes to the remote areas, what are you doing to help assist the gateway to uploading and downloading data?
Yeah, it's a good question. So, in general, if you look at cell coverage, where you have, say, cell coverage not available, you would need to go to a different technology. You can't use that, you have to use satellite-based modems. What we find though is that now between the different companies, you get pretty good cell coverage in most areas. But where you don't, you know the machine's gonna be there for a while, you should have a satellite connection. Yes?
Doreen Galli from TBW Advisors. Are there any particular models of equipment that work best for retrofitting after the fact to add the data sensors?
Yeah, so that's, we see that a lot in actually the ground support industry, where you may take an older piece of equipment like a de-icer or a baggage loader, and it works fine, and you just want to update it. So the challenge there is how much do you want to add to it, and how much time are you willing to put into it? Because retrofitting machines is very difficult to do. You have to splice into the current harnessing. So what we offer is basically taking a kit with a camera technology that can mount right on top of a machine without disturbing the main harness that you have and the main ECU. And then hook the data coming from the camera to an HMI that's also standalone. So you're not disturbing the system that's already there.
Thank you.
Did that answer your question?
Yes, thank you.
Yes, sir.
How do you work with OEMs? Do you supply the entire system for IoT, or is
So it's a little bit of both. So if you look at the component side, so you start with sensors, that's where you have to use, say, pressure, temperature, oil, quality, vibration to monitor that. So we provide most sensor technology to start with the data. Then you just take that information and it needs to be compiled by some type of PLC. So we're in a unique position because we're one of the few companies that does the sensors and all the way up to the cloud. So if you take a look at it from most machineries, we can handle a lot of the different applications. We certainly can't do them all, but we can handle a lot of them with our sensor suite. Yes.
What cloud do you work with?
So it's pretty generic. Most OEMs will have their own. So we've gone to Azure, Cumulocity, AWS. So it's really based on the customer. We certainly can host it ourselves, but a lot of customers don't want us to host the data. They would prefer they do it themselves. So that's why if you look on the slide here, I left the cloud pretty much ambiguous because it really can go to anything. And some want it on site rather than the cloud. So we can do both.
Thank you.
So, so who is your customer?
So if you walk around outside, just about everyone that makes a machine is a potential customer for us. So we, and I think Chad asked the question about, we only deal really with the OEMs. So we sell to the OEMs in the development stage of their product design to incorporate this type of solution. So if you walk around outside or even in the north and central halls, most of the OEM machine builders would be our customers base.
So a purchaser of the equipment, would they know, are you the system behind the success? Or does the contractor or the user know of your company, and do you want them to know of your company?
So it's a really good question. So if you think about intellectual property, right? We provide the mechanisms for the customer to build their IP on the machine. So we're very happy to be behind the scenes where the end customer really doesn't know who we are. Most of these devices are buried in the machine, except for the display. And everyone's used to a display, whether it's like your infotainment system in a car or even just your cell phone. So we're happy to be behind the scenes helping the customer or the OEM develop their own algorithms using our hardware. So the hardware is software agnostic. It has different tools that you can use. And then it's really the customer's job to then own that because that's their proprietary information.
So the one takeaway from your presentation to me is that your company is really involved with all other aspects of manufacturing and logistics and aspects of it all. And what you're seeing is that the digitization of the construction market will benefit from all the innovations and technology advances that happen in other industries and following McKinsey work saying that you're saying that this is probably the commercial industry, construction industry's best opportunity because of all the research done somewhere else.
Yeah, so as I mentioned, we came from the industrial space. So, you know, the revolution of Industry 4.0 hit the manufacturing floor years ago. And now it's just creeping in to various spaces. If you look at agricultural, they're probably a little bit more complex in what they're doing because there's a lot more autonomy in agricultural machines today than not. But now it's trickling down to construction, to the municipal market, which is like your ambulances, your fire trucks, your street sweepers, refuse trucks, and then also in the transportation market. And what we mean by transportation is like your ground support, your ship-to-shore cranes, material handling, the big forklifts you probably see out here. So it is trickling down. And now the biggest thing is do you put too much information out there? What's the right information that a customer wants? And then the second thing is, how do you pay for it? So a lot of companies are looking at different revenue streams. Do they charge their end user a certain dollar amount per month to get the data, or they give it free for a year? Everyone's a little bit different. So if you buy a car, they're collecting the data right away. think some customers are looking to do that as well. And then in a year or two, whenever the warranty is up, potentially, then they can sell it back and create a different revenue stream inside the organization.
Yes, I see in the picture you have I/O modules, which begs the question, is there a maximum number of sensor and the maximum number of modules that your solution can currently hold?
So there is a maximum number for sure, and there is no number. It's basically, you have to look at the traffic on either the Ethernet or the CAN network. How much are you collecting? How quickly are you cycling time? So it is infinite, but it depends on when you're really trying to refresh how quickly you're receiving the data and logging it. If you're only doing it, a couple times a day, then it's pretty much endless. If you're looking to cycle something every 3 milliseconds, then your bus traffic is really going to get heavy, and that's going to slow things down. So then you're limited on that. And what this doesn't show is that, in particular with the PLC and display controller, there's multiple communication networks on there, so you can split up your system network to have 2 different CAN lines going around your body, one just to the engine, so you're kind of increasing the bandwidth of the data that you do want to record.
Very cool, thank you.
Anybody else? Great, well thank you for your time. If there's any questions.